All right, let's talk about the first step to writing out a full hypothesis test. So, we're going to remember all the steps that we need to include in our hypothesis test with this mnemonic device called phantoms. Okay, and so we're going to use this problem to go through an example of that. But first, let's talk about all the parts of those mnemonic or those letters in phantoms. All right. So P is the same thing as it was in panic, where we want to define that parameter of interest. In this case, we're generally doing proportions first. We'll do means later, never in past tense. Do make sure you are clear on that denominator. Another thing is that I think I should add to the qualifications for this is if this is some type of experiment or study that you are doing, then you are generalizing to these subjects that have had that are of interest to what you are trying to figure out. So it's the proportion of mothers who took this new medicine and or the average birth weight of the babies on mothers who took this new medicine, that kind of thing. All right, your hypothesis statement we already talked about, your null hypothesis and your alternative. Describe your conditions. That's where you're going to do random, independent, large enough, and say that the approximately normal model applies. We're never stopping here on these unless the problem leads us to make us think that we want to stop. I generally put center and spread actually down here where I do computing. Whereas our panic model was a 1 proportion Z interval, this is a 1 proportion Z test. And then test statistic is getting that Z score. And then we're also going to be getting a p-value, which a p-value is something that we're going to talk about because that's critical. We're going to talk about getting a p-value and comparing it to alpha and what all that concept means. You will then make a decision. So we're going to talk about if you reject or if you fail to reject. So those are our two options. Reject, null hypothesis, okay? Or you fail to reject. I'll have a discussion with you as to why we never ever say that we accept the null hypothesis. No saying we accept. In fact, let's go ahead and have a little discussion about we never accept the null hypothesis. Let's talk about why, and I'll give you an example for that. Um, let's talk O.J. Simpson. Okay, y'all may be too young to remember the trials based on O.J. Simpson, but because of pop culture and stuff, you may be familiar with that. So, uh, you know, was O.J. Simpson innocent? So, our null hypothesis would be, that he is innocent. Innocent until proven guilty. All right. And then, of course, our alternative is that the person is guilty. Okay. So let's say that if the glove doesn't fit, you must acquit. Or, see, we did not have enough evidence to say that he was guilty. Okay. That, if we do not have enough evidence to say with beyond a shadow of a doubt that he is guilty, then we are not saying that he is innocent. Okay? So think about that. We are not saying that he is innocent. We are just saying that we did not have enough evidence to get the fact that he was guilty. And so, therefore, we are failing to reject his innocence. We are not able to reject this innocence and conclude beyond a reasonable shadow of the doubt that he is guilty. Okay? Big deal. Now, That means that when we state our conclusion and we're stating it in context, we will always do it in terms of comparing this p-value to alpha, which we'll discuss in a minute. And then we state if we have or we do not have evidence of HA. So see, we would say we do not have evidence, enough evidence to say beyond a shadow of a doubt that O.J. Simpson is guilty. Okay? So anyway, there is the general outline for a hypothesis test, and we're going to be starting with one proportion hypothesis tests. Now, let's discuss this idea of this thing called p-value and your alpha, because those are the items that are mathematically the statistical component to giving us evidence or not giving us evidence to reject the null hypothesis. So, a p-value is the probability of getting the sample we get, or more extreme, if the null is true. I want you to think about it this way. The probability of getting the sample or more extreme results if the samples are really centered around the claim. Here's an example. In fact, I show two examples here. Okay? One of them is where I fail to reject the null, and one of them is what happens when I reject the null hypothesis. So let's investigate and look at these two situations. Okay, so see all these p-hats. Okay, this is where our claim is. So this is where the data should be centered, the samples should be centered around if the null hypothesis is true. So if HO is true, then the data should look like this picture. Okay? We don't ever know this. All right. And so the samples will be centered around the HO. Then you take a sample. And so I'm showing you this sample here, this sample right here. Okay? Well, it is somewhat close to the null hypothesis that it could just be sampling variability. So this discrepancy here is just because of sampling variability. All right, so what we find is that there is this thing called alpha, and alpha quantifies, puts a number value to the size of the rejection region, so that if our sample falls in that rejection region, then we will reject the null hypothesis. Well, let's look at what this p-value is based on if it falls in the rejection region or not. Okay, so notice here is alpha. This line is alpha. So that means anything past alpha is the rejection region. Okay, but look, the sample results that we got are not in the rejection region. They are closer to that null hypothesis. And since they are closer to the null hypothesis, look at that blue shaded area I have. That blue shaded area that I have is the p-value. It's the probability of getting that sample or something more extreme. Well, if you compare those two areas, the blue to the striped red, the blue area is greater than the alpha, the alpha region. Okay, so the p-value is greater than alpha. So if the p-value is greater than alpha, then the sample that we are interested in investigating, right here, is closer to the null hypothesis and not in the rejection region. Therefore, it could be in that location because of sampling variability. And ultimately, our decision is to fail to reject. We do not have evidence to reject the null hypothesis. We fail to reject it. All right. So let's look at the other case. Here is a case of a picture where here is our alpha. Okay, and so let's take a look at the rejection region. So this striped area is our rejection region. And so you can see that here is our sample of interest, okay? And the it is far enough away from the null hypothesis that it is in that rejection region. Now, let's look at its p-value. This p-value, oh, I was going to do that in blue. This p-value is the probability of getting that sample or something more extreme if the data is centered around this null hypothesis. That p-value is a smaller amount of area than that red striped area. So because that p-value area is smaller than that red striped area, the rejection region, the p-value is less than. The p-value, poo-poo. I wrote that wrong. The p-value is less than alpha. So therefore, it's in the rejection region, and our decision is to reject the null hypothesis. Okay, so that is a huge deal. What that means is the statistical decision to decide if you are going to reject the null hypothesis or fail to reject the null hypothesis is based on that relationship between the p-value and alpha. And that's the only way. So if you are ever asked to find statistical evidence about something, don't do it with a confidence interval and then say, oh, the number's not in my confidence interval. No, you have to do it with a p-value and compare it to the size of the rejection region. Now, let's talk about that size of the rejection region. If you are not told the size of the rejection region, the default size of that of alpha is 0.05. Default size of alpha is 0.05. So if they don't ever tell you what the alpha is, then that's the value. So if our p-value is less than 0.05, then we will reject the null hypothesis. All right. So let's take a look. We have a couple of songs here to look at to help us remember some of those things, and we may come back to that later. But one of them is the p-value song. Okay. So let me see if I can't pull those up really quickly because I did not do that. Let's see here. Did not have those ready to go. I guess not. I'm not able to pull up a new, there we go, pull up a new window. Okay. So the p-value, do you know what? While I'm pulling this up, I'll just tell you a little history. The p-value song is the very first StatCat song ever. It's such a crucial and critical definition, but yet my students missed it and would not get it correct. It's a very common mistake that people just want to say, the p-value is the probability that the null hypothesis is true. That's not it. The p-value is not the probability that the null hypothesis is true. The p-value is the probability of getting this sample or something more extreme if the null hypothesis is true. So number one, wrong definition is that the p-value is the probability the null hypothesis is true, and that is wrong. So get that out of your mind. All right, so here we go. Let's listen to our p-value definition. Here we go.
The p-value is the probability of getting this sample or something more extreme if the null is true. The p-value is the probability of getting this sample or something more extreme if the null is true.
All right, so there's that one. Now, the other song that we're going to take a look at is this, let's see. We've already done that one. Okay, so this other song that we're going to do is this reminder of the fact that if the p-value is low, that is when you reject the null hypothesis. So here we go. Reject, the p-value is low, reject the null hypothesis.
If the p-value is low, if the p-value is low, the null hypothesis has to go. If the p-value is low, if the p-value is low, the null hypothesis has to go.
Okay, I usually do that song as a class participation one, and so I'll say if the p-value is low, then you reject the HO, and so then they scream, if the p-value, I say, if the p-value is low, reject HO, and so that's what they do, reject HO. If the p-value is low, reject HO. The null hypothesis has to go. Okay, we'll talk about this statistically significant later. But there is the very important information about p-value, the very important information about failing to reject the null hypothesis versus rejecting it, and when you do that. So here is how this problem looks like in the Phantoms model. So this is an ideal solution that you can see what it looks like. So our parameter, this was the P equals the proportion of people selected for jury duty. So see how I am very clear that this is about the people that get selected for jury duty is the denominator. And then the proportion of them that are Hispanic is the numerator, okay? Because we want to see, is that the same as the county's adult Hispanic residents rate, or is it less than 0.19, significantly less than? All right, so here's how our assumptions look. It did not say, so we had to assume that we had 72 randomly selected people for jury duty. We had to say that 72 is less than 10% of all people called for jury duty. And then here for proportions, large enough is greater than or equal to 10. So the approximately normal model applies. Now, let's take a look at this. Our one proportion Z test. That's the name of it. And see over here to this side, over here on this left, is where I wrote the center and spread that I'm going to be using when I compute my test statistic, my z-score. So see, if the null hypothesis is true, then all of our samples will be centered at 0.19. And here is how varied those samples will be. So here's our z-score. The p hat minus the p over the standard deviation of p hats. So it was just 1.41 standard deviations away. It could be attributed to sampling variability. And look at our p-value. P-value is the probability of getting that or something more extreme. More extreme is the direction that your HA is going. So we think it is less than that value, or we're checking to see. So that is the probability of getting that sample or something smaller, and that is 0.079. Well, Look here, obtain this p-value and compare to alpha. I want you to write this just like this. You are defining the p-value equals 0.079. It is greater than the alpha, which equals 0.05, because they did not say the size of an alpha, so 0.05 is the default. So I want it written just like that. Many times students lose credit because the value of the p-value or the value of your alpha is not clear, and you also must always have that connection between the relationship of the p-value and the null hypothesis. Well, guess what? Our p-value was not low, so we are not going to reject the null hypothesis. So we fail to reject the null hypothesis. Now, look at how this conclusion is done. This is just kind of like a summary statement. Of these statements, this one's the least important because you've technically already kind of said those things here. Since the p-value is greater than alpha, I fail to reject HO. Okay, I just kind of just made sure they understood that I understand why I am failing to reject the null hypothesis. Okay, I'm just saying this is why. Okay, this is why I made that decision. All right, so this statement here is always about HA. Whether you do have statistical evidence or you do not have statistical evidence about HA in context, okay? So, since I am not rejecting it, okay, I failed to reject this. I failed to reject it. I do not have enough evidence to reject the null hypothesis and claim HA. There is not enough statistical evidence that the proportion of people who are selected for jury duty who are Hispanic is less than 19%. And then I always stop and go back and see if there's another question that it specifically asks me to answer, because you will get marked off for that. This question said, does this apparent underrepresentation of the Hispanics call into question the fairness of how they select their jury? So do they need to reevaluate the way that they call people in? So there is not evidence that to call into question the fairness of the jury selection system. All right, so there is your introduction to a hypothesis test that we did with one proportions here, but this is the foundation and the same type of format that we use for all hypothesis testing. So very, very important concept. I hope that you followed it. I hope that you understood the p-value and know its definition and understand its definition, and understand if the p-value is low, you're going to reject the null hypothesis. All right, so good luck to you on your assignment.